Myself Prabha J, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic is pseudo nmos logic from the unit combinational logic circuit in the subject of VLSI design. Let us discuss. Yeah, pseudo nmos logic, the inverter that uses a P device pull up and a load that has its gate permanently ground, which means logic 0, and N device pull down or driver is driven with the input signal. This roughly equivalent to use of a depletion load in nmos technology, and is thus called pseudo nmos. Pseudo NMOS logic is a digital logic design technique that modifies the traditional CMOS approach to satisfy approach that is circuit design and reduce transistor count. It is especially useful in application where area efficiency and speed are prioritized over power consumption. Okay. Yeah. Uh, Pull down network, unlike a CMOS logic, where the pull up network consists of PMOS transistor dynamically controlled by the input. Pseudo NMOS logic uses a single PMOS transistor that is always on. The gate is PMOS transistor is tied to ground VSS, making it constantly conductive. Pull down network, the pull-down network is composed of NMOS transistor is just like in standard CMOS logic, and it performs the desired logic function by pulling the output node to ground. Okay, yeah. Um, and we will discuss its operations. Yeah, the PMOS transistor being always on continuously pull the output node towards VDD, that is logic 1. The NMOS transistor is in the pull down network are used to pull the output down to VSS, which is logic 0, when the input condition dictate this create a logic function at the output. The output logic level is determined by the competition between the always on pass transistor pulling the output high, logic 1, the NMOS network pulling it low, which is logic 0. This is the advantage of PMOS NMOS logic is pseudo NMOS logic are its high speed and low transistor count. Pseudo NMOS logic require fewer transistors than conventional CMOS logic, leading to smaller circuit area and potentially faster operation due to reduced capacitance. And the design process is simplified because the pull-up network is always active, reducing the complexity of the circuit. And some of the disadvantage, it has some of the disadvantages. Static power consumption, a major drawback is the static power dissipation. Since the PMOS transistor is always on, there is a continuous current flowing from VDD to VSS when the output is low, leading to higher power consumption compared to CMOS logic. And another disadvantage is noise margin. The noise margin in pseudo NMOS logic are typically worse than the CMOS logic. because of the constant contention between PMOS and NMOS transistor. The pull-up is weaker compared to the dynamically controlled PMOS in NMOS logic, leading to signal integrity issues. And here you can see the inverter. Consider a simple pseudo nmos inverter. Here you can see inverter NAND to NOR to. Let we will discuss the inverter. While consider the PMOS transistor, it always on pulls the output to logic 1, and NMOS transistor controlled by the input. When the input is high, it pulls the output low, which is logic 0. And let me discuss the operation of the inverter. Input equal to 0, the nmos transistor is off, so the pmos pulls the output high, which is logic 1. And when the input is 1, the nmos transistor is on, pulling the output low. The pmos is still trying to pull the output high, but since nmos has a stronger pull down capability, the output is pulled down, but with a constant power loss due to the active pmos. And let I discuss the some of the application of pseudo NMOS logic, which is used in scenario where minimizing transistor count and maximizing speed are more important than minimizing power consumption. It can be found in high speed circuits, memory circuits, and certain types of digital logic where area efficiency is crucial. Yeah. Uh, and yeah, pseudo nmos logic is useful design style for application where area and speed are crucial, and where the power budget allow for some static power dissipation. It simplifies the design process by reducing the number of required transistor, but the cost of increased power consumption and potentially reduced noise margin. This trade-off makes it suitable for certain high-speed and high-density integrated circuit where traditional CMOS logic might be too bulky or slow. Yeah, if you have any doubt, means you can ask me through the comment. We will meet in next video. Thank you.